Hello everybody, welcome to my video on sampling distribution for the proportion. I'd like to start this video by a quick review of where we've been. So we talked about the normal distribution and how we can change a raw data value to a z-score. And with this z-score we can find answers to the questions of what is the probability and finding top and bottom cutoff percents. This formula though only works for one random variable. What if we have a group? Well, it depends now. If we have a group and we're looking at the average, then you're looking at the sampling distribution of the mean. That is, if you want to know, I collect 42 samples and I want to look at their average weight, average IQ, average GDP, average response rate, you want to compare then that sample average X bar to the national average. Of course, you have to divide by the new standard deviation, as I call it, the standard error of when you're dealing with a sample. Please recall, if you have one unit, one item, one person, one data value, you divide by sigma, the standard deviation. If you have a group, you divide by the standard error, and that's sigma offsetted by the square root of n. And so this is our Z transformation if you're dealing with a group. All right, today though, I want to focus on sampling distribution of the proportion. You see, what we're going to have is a statement about a proportion. So we're going to have an old proportion, which we call pi, some population proportion. And then we're going to look at a new proportion, a sample proportion, and I want to compare my sample to the national proportion. That's really what I want to do. I want to see how close is my sample to the projected national proportion. Of course, when you're dealing with proportions, there's going to be a new standard error, a new standard deviation for proportions. And here it is. It's the old proportion times 1 minus pi over n. That'll be our denominator. So let's get to this formula. So first, a previous study reports 80% of parents would give up some salary to have more time home with their family. This is known as flexible schedules. So let us study a random group of 100 parents. First of all, how come I can utilize the normal distribution in this normal approximation to the binomial in many ways? The answer comes in a quick check. The central limit theorem kicks in if we can get enough yeses and nos to submit answers. The typical cutoff is 5. If we can get 5 people to say yes and 5 people to say no, we are good. Now, how do we know how many yeses? Well, if the report is 80% should say yes, and we're studying 100 times 80 is our check. N times pi should be who responds as yes. So 80 people should say yes, they want to spend more time. If the 80% report number is accurate, then 80% of 100, so 80 people should say yes. That also means that 20% should say no. And since both of those numbers are above 5, I know I can approximate my binomial distribution, because that's really what this is a binomial scenario. I'm going to approximate this binomial situation with a normal. And that's awesome. And what's really cool about the central limit theorem is it really provides an opportunity to take a lot of distributions and change them into normal distributions and work primarily just with the normal distribution. So it's very, very important to understand first the normal distribution before you get to utilizing the sampling proportion. All right. So what we have here is we definitely have the ability with both of these being above 5. That is, again, n times pi gives me how many successes I should have in a group of 100. There should be 80%, which means the opposite, 20%, should say no. Both of these numbers are above 5, and by the rules of the central limit theorem, if both yeses and nos are above 5, we are good to go to use the Z distribution. Awesome. So what do you need in the formula? Well, in the formula, you need a sample percent. Well, let's read the question now. So we have already done part A. How come the normal distribution applies? Because our yes and no's are above 5. That's why. And that's 5 in count. Part B then. What is the probability that less than 75 in the group would approve of the schedules? So we know 80% should. So what is the probability that less than 75 in some random group would approve? That's what we're trying to do, is try to figure out what are the odds less than 75 would come in and say they approve if the national average is 80%. So first I need the sample proportion we're studying, and that's 0.75. By the way, when you're entering into Excel, please make sure, all right, please make sure you are utilizing decimals. If you're not utilizing decimals, you will not get an accurate answer. Of course, we need the spread, the denominator. Well, the spread by a formula is the square root of pi times, parentheses, 1 minus pi divided by n. How do I know this formula? This formula is from grad school, and what we do in this class is we utilize our formula sheet. What you have to know is you have 3 different scenarios in basic statistics. You just got to know when to use which z transformation. You use this transformation when you're looking at a single file, one random female, one random turtle, one random stock, one random patient. I don't know what we're looking at. Utilize this formula if you're looking at a group of people and you're studying their average. That's why it's called the sample mean. We're going to utilize this transformation, this formula, if we're looking at the sample average. If we're studying a quality, a proportion about the population, then you're going to utilize this. And believe me, there are other formulas. These are the basic 3 we get used to in the first level statistics course. All right, back to work. And that's why, again, my denominator, look at your denominator, it's square root of pi times 1 minus pi over n. That's what I wanted to get to. Your major thing to understand is to know which one to use, which one of these formulas to use, z transformations. Then it's just plug and chug. So I now know the denominator. So the typical formula for z, by the way, is your raw data value, which is the sample, minus the national statistic, pi, divided by the denominator, which is the spread factor. That's really how z works. It's your sample minus the national statistic, always divided by the spread factor. The spread factor is based on the distribution. Boom. We get a z value that's negative 125. Is that expected? Well, first of all, is negative expected? Yeah. I'm saying 75%. That is below national statistic. Since I'm below national statistic, I should be a negative. Do I expect 1 1/4? Well, the denominator is the spread. That is, here's 80. 1 unit below 80 is 76. Remember, we're at 75. So if we go 1 1/4, we would be at 75. So this z value makes sense. From there, we utilize either the table and look up negative 125, that is the normal table, or we utilize Excel, which says give me the z value. I will do the calculus, if you put the 1 there, of course, put the 1 to make sure it does the calculus. I will do the calculus to find you the probability that something occurs below that z value. I need the z value to utilize norm s dist. Without the z value, you cannot do norm s dist. So this would be the probability below this z value. Well, the z value is actually the same value as 0.75. The p and the z are in the same position. This is just a real statistic. This is the z statistic above it. Both of them are on the left of the normal table, and the area below that is 10.56%. And because this was less than, I know this is the answer I'm looking for. And so this is our first conclusion. What is the probability less than 75%? There's a 10% chance that's going to happen. Given the national statistic is 80%, the odds of a group coming in and saying less than 75% is not likely. So if you were trying to vote on something and you needed 3/4 approval, you're pretty darn sure you're going to get 3/4 approval here, 3/4 being 75%. If you're in the workforce and you're the boss and you're wondering, are we going to pass a movement to have a flexible schedule, and the only way it can pass is by rule, it had to be 3/4 pass, you're pretty dang sure, unless you do something right now, you're going to pass this rule about flexible schedules, given the national statistic of 80%. Because again, the chances we're less than this number is 10%, which means there's a 90% chance we're going to be above 75% in that group of 100 parents. This is how we turn a simple probability into a very huge topic. It's all about passing laws and understanding if laws will pass. It all starts with, what is the national statistic? What do we feel about the national statistic? How much do we trust it? Then utilizing the sampling theory, I can put odds on a law passing or not. Cool. All right, let's wash and repeat. What is the probability that more than 90% in the group would approve the schedule? Let's say we really needed 90% in order to pass the law in the business, and we could say we would all try to do a more flexible schedule. What are the odds of this happening? If we all voted on this, what are the odds of this happening? Well, here's what we do. We would need our n, 100, that hasn't changed. We need our pi, that hasn't changed, 0.8. That means our checks are still the same. Yes or no are still 80 and 20, so I can still use the normal distribution. Yes. You might be saying, why do I care that I can use the normal distribution? Look here. Do you see how that says norm S dist? That's the normal distribution. You can't use the normal distribution unless you are allowed to use the normal distribution. So these checks are my assumptions. And again, it'd be 80 and 20. Because my n and pi haven't changed. All right, what's my new p-value? It's 0.9. We're wondering, is 0.9 that far from 80%? That's really what it is. Is 0.9 that far from 80%? Well, it depends. I need the spread factor. As before, the spread factor hasn't changed either. The formula for the spread factor, look at your formula again, only deals with the pi's, the historical percentage. In this class, by the way, pi stands for the proportion of the population. All right? So now, what is z? Well, z by definition is your sample minus the population statistic divided by the appropriate standard error, in this case, the denominator. And there we go. My z value is 2.5. Does it make sense? Well, again, if the spread factor is 4%, how far are 80 and 90 apart? Well, 4 plus 4 plus 2. So 2.5 of the spread factor. So that's why the z makes sense. If you understand the spread factor, you can understand why 2.5 makes sense. It's 2 because that which is positive because 90 is above 80%. It's 2.5 because we're jumping at 4% each time. So 2 jumps of 4 and then a half a jump, which is 2, makes you go from 80 to 90. Of course, we can utilize norm S dist to find the area, that is the probability, below this marker. And that's the other reason why we want the z value. The z value allows us to utilize calculus and utilize the normal distribution and find probabilities. Without the z value, it would be very difficult to find certain probabilities. Of course, read the question. We want the probability more than. Well, to do more than, just please recall, equals 1 minus what's below. Think about that. If you know there's 99% chance you're below this mark, that leaves you with 0.006 chance to be above that mark. So if the measure, if the law, if whatever the rule is, had to pass with a 90% or more, I'm going to say it's not going to pass. At 90% or more, it's not going to pass. Because the feeling, again, is the majority of the time, when we randomly take 100 parents, we're going to get 80%. Somewhere around 80% plus or minus 4%, okay? Somewhere around 80% with a plus or minus 4%. So 84 to 76. Anytime I take a group of 100 parents, and that's what I think. Here's a group of 100. 82%. That makes sense. Here's another group of 100. 77%. Okay, and what I mean by the percent is percent that would give up salary for more time. That is a flexible schedule. So take 100 parents, 78% said yes. That makes sense because it's close to 80. Again, close meaning the spread factor of 4%. What about 90? Is that too far from 80? In this case, it is because 90 has a z value of 2.5. In the probability below, which is its percentile value if you care about, is we're in the 99th percentile for this option, which means there's not much chances to be above that number. So if it does happen, there has clearly been some marketing towards flexible schedules, or opinions have changed, right? We could say this is the opinion, but if this number comes up in the sample, if a number comes up above 90 in the sample, we might start thinking maybe this number has changed. We just ran a statistic too far away from 80, so maybe we should do a major study and see if times have changed. Maybe more people will be accepting of flexible schedules. You see, a national statistic is only as good as time. As time moves on, things may change. Now, what I love about Part D is what would happen if you change the sample size. What do you think are going to happen to all these numbers? That is a very good question. What happens when you change the sample size to 200? Well, pi doesn't change. That's still 0.8. I know the checks will definitely work because 80% of 200 is 160 people. And that means 20%, the people that will say no, is 40. These two both have to add up to n. Again, if I have 200 people and I expect 80% to say yes, 80% of 200 is 160. If I have 80% that's going to say yes, that means 20% will say no, and 20% of 200 is 40. Both of these are above 5, which means I can use the normal distribution. I do not have to resort to utilize the binomial distribution. That's really what it is. This question is really a binomial question, but because the central limit theorem kicks it into normality, I'm using normality, and that is awesome, my friends. All right, what's our sample we're trying to cross? We're going to repeat question C, so that's 90%. What's our denominator? Well, that has changed. Our denominator is the square root of p times, not p, I apologize, pi, let's do it right, pi times 1 minus pi, all divided by n. So that's the first thing, and yes, I know I didn't add the extra parentheses. Thank you, Excel. So first thing to note, if I had a sample of 100, that was your spread factor. A sample of 200 has this spread factor. Notice the spread factor went down. It went from 4% to 2.8%. Does that make sense? Well, if you've been following along in my videos, that is the normal video, then the sampling mean video, and now the sampling proportional video, you'll see that as the sample sizes increase, then your spread factor has to come down. That is just good old logic. The more people you have, the more people will vote close to average, which is 80%. And the more people that vote close to average, the tighter everybody's opinions get. So it's very hard to move a group of 200 because of that 2.8%. Opinions are really, really close to 80% in a small group. So again, the spread factor goes down. What does that do to the z value then? If the spread factor, the denominator, gets smaller, what will happen to the z? Now let's think about, fourth grade algebra. The numerator hasn't changed, that's p minus pi, but the denominator has gotten smaller. If the denominator gets smaller, what happens to your whole fraction? You guessed it, it gets larger. That's good old algebra. And so now it's even more impossible to get to 90% if we have 200 people. It would be even harder. If, again, 80% typically say yes, it's hard to move larger groups. That's just the common sense. It is hard to get a group of 200 to sway their opinions that far from this national statistic, if the national statistic is true. Can we find the percentile, as I call it, or the probability you're less than this? Sure. Always use 1 again. Just to repeat, always use 1 in the cumulative. And yes, that probability got higher. Why did it get higher? Because your z value got farther. The farther the z value, the higher you are in the percentile. This would be now in the 99.98 percentile because we've moved up the sample size. This is very important. Sample size goes up, denominator goes down. Denominator goes down, z gets bigger. Good algebra. Z gets bigger, the probability below it gets more because the z bar is the bar that's moving left and right. And if z gets farther away from 0, that means more area is to the left. Which means, if I want to answer this question, the area The 1 minus, and I don't have to do that again, I apologize. The 1 minus that should be extremely rare air. That is, it's going to be extremely hard to get this crowd of 200 to get to 90%. It is going to be extremely hard. So if a person does it, that's exciting. If you know these are your odds, right? You know that 80% of the parents would do this. All right, so you have 200 parents coming in for a vote. You need 90%. What are the odds of it? Well, right there it is. 0. Really, really small. So can you do it? Well, of course you can do it. It's not completely 0. There are odds. It's like, getting hit by lightning. There's a chance. So the question is how could you do it? Well, you have to figure out a way, marketing, personal, hitting them in the heart, really trying to punch them through and vote that way. Or maybe the statistic is wrong, and so that's why this showed up. This number could change through the years. It all depends when this number was reported. Excellent, guys. And this is how you deal with the sampling proportion. Please pause the video now, and you try example 2. All right, guys, we're back. So here we are. Where are we at? Well, example 2 now. A recent study reports that 70% of the customers of a company votes favorably on a customer satisfaction survey. Got it. It is known that if the favorably number dips below 60%, then the CEO will be fired. All right, so bottom line, what is the probability in the coming year this could happen if we sample 200 customers? So again, the reports typically hover around 70%. They like the customer. They're happy with the company. It has been well documented if that number ever dips below 60%, the CEO is fired. So if you're the new CEO, part B, would you want to take this position? Well, it depends. What is part A? What are the odds in 1 year somebody could be fired? Well, I'm going to attack it just like part A. First, I need to know my N. It's 200 because that's the sample size. I need to know my pi. Now, pi is the past proportion, the population percentage, the past number until things have changed. So that's pi. I need to check the central limit theorem. Well, 70% of 200, that's 140 people. That's plenty. That's well over 5. If 70% should say yes, then 30% should not be happy with the product. And 30% of 200 is 60. And the central limit theorem says as long as both of these are above 5, the binomial distribution can be turned into the normal distribution. And how do you turn it? Utilizing the formula. So here we go. What is the sample percent we don't want to hit? 60%. Because if we hit 60% or below, the CEO gets fired. So what's our denominator? Well, the denominator, and again, you just got to look up the formula. It is pi times 1 minus pi divided by n with the square root above that. So it's n in the denominator. So it is pi times 1 minus pi divided by n, all square rooted. Boom. That is our spread factor, about 3%. That is our spread factor, our jump factor. All right, so what's our z value? Our z value, by definition, a z value is your sample value minus the national statistic divided by the spread factor, the standard error. So I get a z of negative 308. I'm going to let you know right away, I don't even have to do any more work. It's pretty hard to be lower than that number. It's pretty hard. Again, the typical bounds are negative 2 to 2. If you're below a negative 2 or above a 2, you're in the top 2.5%. That's what we keep in our head. The bottom 2.5% is at negative 2. The top 2.5% live at 2. You just memorize negative 2 and 2 are the top and bottom 2.5%. So if you see a negative 3, you're doing even better than the bottom 2.5%. So this number's the probability below. The probability you're going to score below a 60%, that is a CEO, is going to get torched in the favorability is, well, let's check it out. That number, which is 0.1%. 0.1% is the chance the CEO coming in will get fired. How do I know? Because I understand that this scenario is a normal distribution. And all I need is the proper Z formula. I can't stress that enough. Knowing your proper Z formula. One person in average, that's this. A group and comparing to national average, that's this. A proportion comparing to national statistic, that's this. I'll pause so you can take a picture of this. All right, now we move on. And these formulas are well known. But if you'd like to pause the screen, take a picture of the formulas so you can utilize them later, please do so. All right, so that's why the Z value is this number. I just been doing normals most of my life. And if the Z value is past -2 or above a 2, you're looking at a rare occurrence. So if you get to a -3, this is an extremely rare occurrence. And that's why the area below it is less than 1%. So there's a less than 1% chance the CEO is going to be fired. So my answer to part B, oh yeah, I'm taking the position. Because there's less than a 1% chance I'm going to be fired. That's really why I would take it. I mean, the money, I'm going to be the CEO. Why not take it? Right? That's the best thing in the world. Why not take it? So would I take it? Yes, I would take it in a heartbeat. Because again, the chances I get fired is less than 1%. Now, this is the fun part of research. If that number does dip below 60% next year, you could look back on it and go, I wasn't expecting that. It should have never happened. So the question is, what happened? Did the CEO run the company into the ground? Was there something else? Was a new product brought to the market that killed your company? Was a new governmental law put in place that killed your company? What happened? So the favorability ranking fell down. Did your CEO show up naked somewhere he or she wasn't supposed to? Did the CEO say something very, what's the word I'm looking for, not cool on Twitter or Facebook that killed the company? All right? We've all seen these scenarios out in the world. So even though the CEO comes in and says, yeah, there's no chance of me being fired, of course, something weird could happen. And so if the CEO does get fired because the favorability does below 60%, you know it had to be something weird because it shouldn't have been happening. That's the idea right here. It should not dip below. This favorability number should not happen to a CEO because of this right here. So something must be wrong, and one has to look into it if the CEO does get fired. But bottom line, I take the position because there's no reason I should be fired unless I do something really incredibly wrong as the CEO. Excellent, guys. Thank you for watching this video. Stay tuned.